We are continuing with area, but this section is called compound regions because we are going to have sometimes two curves, probably not many more than two curves, and we want to find possibly areas between them or areas to the axis. It could be either. So if you have two curves on top of each other, which means it would look something like this, you might have a parabola and a nice lovely straight line. If you are trying to find the area between two curves, then you can use this rule that is here. It says area equals the integral of the upper curve minus the lower curve. So upper curve means whichever one's on top, which in this case is the straight line, and then you go minus the parabola. And the numbers that are on your integral sign would need to be the points where those two graphs intersect. So there might be some simultaneous equations that might happen in these questions as well. Okay, but not all of the questions in this section will be like that. If we have a look at question 1, it is a little bit different. It says, sketch the curves y equals x squared and y equals x minus 2 squared on the same axes. Now, these are graphs that we are very familiar with. Y equals x squared is our basic parabola that goes through the point 1, 1 and comes up like this. The x minus 2 in brackets squared just moves the vertex over 2 places so that it is at x equals 2, moving to the right. And it would also have the same steepness. So if we go one space on either side of that, it is also going to go through the point 1, 1. And if I wanted one on the other side, it would go through 3, 1 as well and comes up like that. So they are my two graphs. It says to sketch them, and it says in part B to shade the region bound by those two graphs and the x-axis, which means I'm not really going between them. They're not on top of each other. They are next to each other, and I'm after this little part of area in here that is between them going down to the x-axis. Part C says to shade the area, find the area bounded by this shaded region. Okay, so there is two sections. I could integrate the y equals x squared graph between 0 and 1. Okay, I'm going to do that over here. Integrate between 0 and 1 the x squared dx graph, and that will give me this little part, the red bit that I just shaded in. Okay, but that means I'm also going to have to find out the integral from 1 to 2, but that is of a different curve, which is x minus 2 in brackets squared dx. There is two different curves that I need to integrate here. Yeah, it is symmetrical, so in this one it would be times by 2. That would be a shortcut, but I'm going to do it this way just because I want you to see that you might have to do them separately because it's not overly common that they are going to be exactly the same. All right, so first one, add 1 to the power, divide by the power between 0 and 1. Okay, subbing in, we get 1 over 3, that would be cubed, but that's still 1, minus 0. So that's just equal to a third. And thanks to David's suggestion, we do know the other one should hopefully be a third as well, but let's double check. Integrating, that's good practice. Add 1 to the power would make power of 3. Divide by the power, and you would normally times that 3 by the number in front of the x, but because it's a 1, I can kind of leave that bit off. And it is between 1 and 2. Subbing in, I get 2 minus 2 in brackets cubed over 3. That's just 0. Minus, sub in 1. 1 minus 2 in brackets cubed over 3. So because this is 0, 1 minus 2 is minus 1. Cubed is still minus. But because this is negative and that is negative, it becomes a positive 1/3. Okay? The total area is going to be equal to those added together. So 1/3 plus 1/3, which is 2/3. And we need to remember to write units squared. Do you guys need to talk the whole way through this? Because it's kind of annoying me. I don't know about everybody else. Thank you. Question 2. Find 2 points where the curve y equals x minus 2 in brackets squared meets the line y equals 4 minus x. So it says find the 2 points. That's simultaneous equations. I need to know where they intersect. This is going to be equation 1. This is going to be equation 2. I can sub equation 1 into equation 2. That will mean that x minus 2 squared is equal to the 4 minus x. Okay, I have to expand that to try and solve it. Expanding my bracket, I will get x squared. Take away 4x plus 4. And that's equal to 4 minus x. Now I want to collect everything up on the left-hand side with the x squared first. So it's positive where it is. I'm going to move these 2 terms across. So it'll be x squared. Adding 1 will make negative 3x. And I have a plus 4 here, and I'll be subtracting 4 when I move that across, so the 4's disappear. And it's just equal to 0. Now that I have a quadratic, I need to factorize it properly to use null factor to find my solutions. I can bring out a common factor of x. So x bracket, x take away 3 equals 0. And using null factor, x equals 0 or x equals 3. Because these are points, the x values are not enough, I have to find the y values as well. You can sub these into either one. I think 2 is the easiest. If I sub 0 into there, it would be 4 minus 0, which is just 4. So I would get y equals 4 for that one. And when x equals 3, 4 minus 3 is 1. So my 2 points of intersection are 0, 4. And the other one is 3, 1. Okay, so this is setting up the question so that we can find the area. Second part. Now let's draw this and shade the area that we are after. Okay, first of all, the parabola. It was x minus 2 squared. We already drew this today. So the vertex for that is at 2. The y-intercept is at, where's the y-intercept? 4, because it'll be when x equals 0, so 0 be minus 2 squared, which is 4. And it will be coming up. Oh, that was a bit weird. Coming up like that. Okay. Then the line, y equals 4 take away x. The y-intercept is 4. So it's here. The gradient is negative 1, but what might be better to find is the x-intercept. X-intercept, where's my equation? Up here. X-intercept is when the y equals 0. So if this is 0, x is equal to 4. So 4 is going to be here. And that, is not a very straight line, but that's all right. There is my line. The area that I'm after is the section between the two of them. I have already found the points of intersection. that's what we did in part A. This point of intersection is the 0, 4, and this point of intersection is the 3, 1, and they almost look pretty accurate on my graph, which is good. Happy days. Okay, so part C, find that shaded region, which is when we finally get to integrate stuff. This is when we can use that formula that was at the beginning. I'm going to find the area by integrating the x values are the x values of these intercepts. So 0 to 3, that's where my two curves, what's happening between 0 and 3. And I want the top graph, so of these two, then they're overlapping here, the line is on top. The equation of the line was 4 minus x. Then I have to subtract the lower graph, which is my parabola, and just be really careful, because you're subtracting an entire equation, that minus sign is going to have to expand through that second equation. Okay, so written like that, which is okay, because it's factorized, so it's just that minus sign is just sitting at the front for this one. It can all go in the one integral sign. This is what makes it easier and hopefully faster. Let's integrate. Integrating 4, we get 4x. Integrating minus x, we add 1 to the power, divide by the power, so x squared over 2. Integrating the bracket, leave the bracket, add 1 to the power, divide by the power, and you would multiply by the 1 that is in there. Between 0 and 3. And then sub in. So it will be 4 times 3 minus 3 squared over 2 minus 3 minus 2 cubed over 3. If I sub in 0, is everything going to cancel out? The first term in this, so that's subbing in the 3. That's 0, that's 0. Is that 0 by 3? There's actually something still there because of the minus 2. So this is where you've got to be careful with zeros, because they don't always make nothing. So that is minus, I'm going to go, I'll do the whole thing, 4 times 0 minus 0 squared over 2 minus 0 minus 2 cubed over 3. What does that equal? And I need you to tell me, because I think my answer is wrong, because I don't think I did that last number. Let's calculate it. 59. 59 over 6. Everyone else got the same thing? So that's 9 and 5, 6. Slow down, slow down. Was it? Did you get it? So it wasn't a shock about the answer, it was something else happening. Yep, I got the same thing. 9 and 5, 6. And units squared. Okay, next question. All right, number 3. Find the 2 points where the curve y equals x squared minus 4x plus 2, so it's another parabola, and the line y equals x minus 2. Find where they meet. Simultaneous equations again. So equation 1, equation 2, and we're going to sub 1 into 2, which means I get x squared minus 4x plus 2 equals the x minus 2. Just like last time, move everything to the left, which will be x squared minus 5x plus 2 plus another 2 will make plus 4. So we do have our 4 quadratics still there this time. Factorising the trinomial, what times is to give positive 4 and adds to give minus 5? Yep, minus 1 and minus 4, which means x equals 1 or x equals 4. Once you find the x's, remember to come back and find the y's. Let's put it into this one again. So it'll be 1 minus 2, which is minus 1. Sub the 4 in. 4 minus 2 is 2. And I like to write them as points because they are points of intersection. So 1 minus 1 and 4, 2. Okay, so like last time, part B, we now want to sketch it so that we can find the area. The sketch looks like, now, all right, this parabola back here, can I factorize that parabola? What times is to give 2 and adds to give minus 4? It's not going to be nice. We could probably use a discriminant. We could use a quadratic formula and get them as decimals. I don't think we need to be this accurate. The plus 2 on the end does indicate the y-intercept, which would be here. If you wanted to find the turning point, that would be one thing that would be a good thing to find. So you could do x equals minus b over 2a. That's our turning point formula, if you remember that. So that's going to be a positive 4, because the 2 minuses cancel out, over 2 times 1, which is 2. So it'll be at x equals 2. If x equals 2, sub 2 back into the parabola here to find out the y value, and we'll have our point. Is it negative 2, is it? All right, so that means y equals negative 2. So 2, negative 2 down here. My parabola is coming up like that. I'm not going to bother finding the x-intercepts because it's not really going to help me. The line was x minus 2, which means my y-intercept is at minus 2 down here, and my gradient is a positive gradient, so I know it's coming up from there. What is my x-intercept? Do you see the equation? What would be the x-intercept of this? Y is 0, so x equals 2. So x equals 2 is there, apparently. Okay, so my line's coming up like that. Okay, it's still a bit rough, but at least we know roughly where things are. The 2 points of intersection, we worked out that this one here would be the 1, negative 1, and that point of intersection must be the 4, 2. So again, not too shabby. Things look like they're in the right places. No, I don't need the y. Okay, now to find the area, I'm finding the area between the two, which means integrate top one minus bottom one. This time, my x values that I'm looking between, my two curves here, is between x equals 1 and x equals 4. So integrate between 1 and 4. The top curve is the line again. So the line had equation x take away 2. Then I want to subtract the bottom one, which was the x squared minus 4x plus 2. So this one, this is what I was thinking about before. This minus sign, I'm going to have to expand that in before I can integrate. I can also collect up like terms before I integrate. So let's do that. We have 1, 4. How many steps do we want to do this in? Can we do it in one? Highest power of x is that x squared. So it would be a negative x squared when I expand it out. The x terms, I've got 1 here, and timesing that through would be a plus 4. So 1 plus 4 makes a positive 5x. And then the constants, I have a negative 2. Expanding that in would be another negative 2. So it's minus 4. How'd you guys go with that? Is that all right? We're expanding and collecting all at the same time. Is that a yes? No. Will says no. Okay, extra step would be this. You're going x minus 2 minus x squared. You're timesing that minus in. Plus 4x and minus 2. So I'm just timesing this minus into that bracket to get this. And then what I'm doing is I'm collecting the like term. So there's my minus x squared. I brought that out first. The x with that x, 1 plus 4 makes the 5. And the minus 2 makes the minus 4. Okay? All right, so now we can integrate. Add 1 to the power, divide by the power. Next one, 5x, add 1 to the power, divide by the power. And minus 4 needs to get an x, so minus 4x. Between 1 and 4. Subbing in, and then will be some fun calculator time. It will be negative 4 cubed over 3. Now, this doesn't actually matter for this question because it would be the same either way. But is that negative sign cubed? Or is it the 4 that's cubed? Is the minus sign cubed or just the 4 cubed? Just the 4. Okay, as I said, it wouldn't make a difference for this question, but it would if that was an even power. Okay, so you need to know which part is the part that's got the power on it. The minus sign was sitting out the front of the x. It wasn't inside it. Okay. All right, then the next one, plus 5 times 4 squared over 2 minus 4 times 4. And then sub the 1 in. So minus 1 cubed over 3 plus 5 times 1 squared over 2 minus 4 times 1. Now, me personally, especially when I'm typing this second one in, all these 1s in here, don't do the powers. You just type it in as negative 1 over 3 plus 5 over 2 minus 4. Okay, timesing by 1 doesn't do anything, okay? Just make it easy for yourself typing them in. Did anyone get an answer? 9 over 2. Yes. Units squared. Yep. It's just the way you read them.
That's the opposite of why.
Yeah, I know.
I go for them.
I think it's because when you read it off your graph, I'm going from 1 to 4. You always do the smaller number first. So when you read it, the correct way to read it is that I'm integrating from 1 to 4. But when you write it, that means you're doing the bottom and then the top. 1 to 4, 1 to 4. Yeah. Okay, question 4. Find the area between the curves. Now the last two that we did, there was parts A and B, I think one of them had a C, where it stepped you through it, what you had to do, whereas this one's just going, nah, work it out yourself, here's your 2 equations, you got to do it, all right? You've got to do the simultaneous equations. You might need to draw a graph, and then you have to find the area, okay? So without any prompts. So we know, first step, solve simultaneously so that we know where they intersect. So equation 1 and equation 2, sub 1 into 2. So that will be minus x squared plus 4x minus 4 equals x squared minus 8x plus 12. I want the x squared positive so that I can hopefully factorize this thing. So this x squared is positive, which means I'm effectively going to move everything from this side that way. I'm just going to write it on the left. So it will be 2x squared. Subtracting the 4x will give me negative 12x. And then I will need to add the 4 to be a plus 16 equals 0. What should I do with this? Divide by 2. Excellent. X squared minus 6x plus 8 equals 0. Can I factorize it? Yes. What is it? Yes. Minus 4 minus 2. Which means from null factor that x equals 4 or x equals 2. What do I do next? Sub them back in. Oh, they're both pretty nasty this time. 1, okay. So put it in here. You're going to have minus 4 squares. That's minus 16 plus 16 minus 4. That's just minus 4. Then subbing in 2 would be negative 4 plus 8, so 4, minus the other 4. Oh, I think I did it wrong. It's meant to be 0. Did something wrong in my head. Did you get 0 when you put that in? Yes? All right, so the points of intersection are 4, negative 4, and 2, 0. Draw yourself a little graph. Let's see what this looks like. 2 parabolas. Let's just come back up here for a sec. This parabola, it's upside down. Where's the turning point? Is what I wanted to find. Okay, yep. Let's see if we can bring out the minus, which would be x squared minus 4x plus 4. What does that equal? Can I times to give minus 4? Yeah, I can. So that's x minus 2 squared. Hey, we did that one already. Kind of. Well, no, it's plus 2, yeah. All right, so that we can draw that one now. What about this one? Factorize it. It would be minus 6 and minus 2. Okay, so factorizing it means I can find my x-intercepts. So I did that in different colours because I didn't want it to be my simultaneous equations. But my graph, how much space do I have down here? My graph will look like this. So the first one was minus x minus 2 in brackets squared. That means a vertex at plus 2 and concave down. If we wanted to know where's the y-intercept, where's the y-intercept of this? That's 0, so it's minus 2 squared, which is 4. It'll be the minus sign, at minus 4. So down here, minus 4, there is my first parabola. The second parabola has zeros at 6 and 2. So change colours. 2 and then 6 down here somewhere. I'm not going to, oh, wait. No, I'm not going to. I'm not going to find the turning point. It's going to come down here somewhere. I don't really know how far down it's going. And it comes up like that. So it is this teeny tiny little bit of area in here that I'm trying to find. Now, I don't know if it's a turning point or not, but I do know that point of intersection. Where is that point of intersection? Oh, my graph is way out of scale then, isn't it? Oh, well. Third one wasn't as good as the first two, but anyway. 4, negative 4 is that point there. I should have gone down further. Go down further. This one here is the 2, 0. Okay, so my y-axis got a few problems there because it doesn't go down far enough. Okay, but we can see the little sliver of area that we're trying to find. So to find it, we integrate. Integrate, yes. Because the green one is concave down, we know that one will be curving out that way, and the purple one's concave up, so it's going to have to be underneath it. Concavity kind of tells me which way they're going around each other. All right. The x values are from 2 to 4. 2 to 4. The top curve is the green one. The green is on top of the purple in that little bit of area that I'm looking at. So just this little sliver, the green graph is on top. Green graph is on top. And that one had the equation, and I'm going to use the expanded one because it's going to be nicer to do all my stuff to. The expanded version of that was the minus x squared plus 4x minus 4. Then I have to minus the bottom graph, which was the purple one, which was the x squared minus 8x plus 12. And it's in brackets because I have to put that minus through. Okay, let's do that and collect at the same time because we're probably running out of room. I know I am. So we have minus x squared minus another x squared. So negative 2x squared. Then we've got 4x, expand that minus into there, will be a plus 8x. So 4 plus 8 makes 12 x's. And finally, the minus 4, minus comes in again to make a minus 12. Minus 4 minus 12 is minus 16. What's the matter, Will? Are you all right? You're good? Okay, integrate. Minus 2, add 1 to the power, divide by the power. 12x, adding 1 to the power would be x squared. I didn't write the 12 there because if I divide the 12 by the 2, it will become a 6. And then minus 16x. If you need to do more steps, then please do. I'm just trying not to make this spread out into multiple pages. But if you need more steps, you can definitely do them. And then sub in. So minus 2 times 4 cubed over 3 plus 6 times 4 squared minus 16 times 4. That's the first one. Then minus 2 times 2 cubed over 3 plus 6 times 2 squared minus 16 times 2. And Grace has got the answer. Tyler has the answer this time. 50 and 2/3? I didn't get that. I got 8 over 3. Good. So 8 over 3 or 2 and 2/3. It doesn't matter if you're doing improper fractions or mixed numerals. I don't care. They're the same thing. Units squared. Done, done, done.